Okay, today we're going to start talking about lesson 4.6, which is multiplying decimals times decimals. And we know how to multiply decimals. Multiplying decimals, the steps are super easy. Ignore the decimal, multiply it like normal, count the number of decimal places in the problem, put that number of decimal places in the answer. So before we even start diagramming, let's answer these questions. What's 3 times 4? Yell it at me.
12.
Everybody knows what 3 times 4 is. So it doesn't really matter what place those are in. 3 times 4 is going to equal 12, no matter if it's 30 times 40 or 3/10 times 4/10. 3 times 4 is always going to equal 12. So we can put that in right now. Multiply and ignore. How many decimal places are in the problem? 1, 2. How many decimal places go in the answer? 1, 2. So I already tell you that's our answer. But you knew that. So I'm not giving away any wild secrets or anything here. How about down here? We have a 4 and a 16 if we ignore the decimal. What's 4 times 16? First person to get it, yell it at me. We'll confirm it 3 times.
64.
First person says 64. Confirmed once, confirmed twice, 3, 4, 5, 6, and a whole bunch of times, especially by those of you guys that are just putting a thumbs up. We're going to need you to actually do the math to confirm it, please. But yeah, you're right. It's 64. How many decimal place values are in this problem? 1, 2. 1, 2. Answer, already done.
Wow.
Now, here is the question of the century that you cannot answer without drawing this math. Why, when you multiply 2 numbers together, which you always do, and you always get a bigger number in the product, why, when there are decimals involved, does your number and your product turn out to be smaller than your multiples? It's not smaller than this multiple, but it's a lot smaller than this multiple. Why does that number shrink? And I can tell you, without drawing it, I can't answer the question. It's really difficult. But when I draw it and I say, hey, think about this, you're going to have one of those, dude, that makes a lot of sense kind of moments. So, first step, shade the first number vertically. So that means our first number is 3/10. We know that if this is a 100 block, tenths are a full stick. So I'm going to vertically shade in 3/10. Not hard, easy enough. Horizontally, I'm going to shade in 4/10. 1, 2, 3, 4. Three tenths times 4/10. And you remember when we're using an array to do multiplication, like the multiplication squares are in the front of everybody's planner. You go over, and you go up, you go over 3, you go up 4, there's your 12, right? That means there are 12 squares when you do that as a graph. Remember doing the array very beginning of the year, super early, talking about different ways to do multiplication. Super easy way to do multiplication, very inconvenient if you're using bigger numbers. This is an array, but it's flipped inside out because these numbers are smaller than 1. Is this 1 or is this a piece of 1?
Piece of 1.
Is this 1 or is this a piece of 1?
Piece of 1.
So get ready, here it comes. If I offer you a piece of pizza, you're going to be like, I'll take a third of a pizza or a fourth of a pizza. It sounds delicious. What if I offer you a piece of a piece. Not even worth it. Might be kind of gross, depending on if they cut it or if they chewed it. The reason when we multiply two decimal numbers together, we get a smaller product is you're getting a piece of a piece. So instead of 3/10 or 4/10, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hundredths. It's just like an array, except for it's a piece of a piece array. You could do this like this every time. Now, what about this situation? Can you use hundredths in your multiples? No. This only works with just tenths or whole numbers. It won't work because we won't cross them over. If we're just doing one square, we can't cross them over as easily. But if you're multiplying tenths times tenths, could you use this as a quick way? Yes, every single time. This is one of the rare times that diagramming is actually quicker than the algorithm, unless it's 3 times 4 and you already know it. So what happens here? We've got whole numbers, we've got multiple squares. It looks fairly complicated, right? Yeah, it's really not. I'm going to work backwards, though, and the first number I'm going to diagram is my horizontal number, my 1 6/10. How do I use this to diagram 1 6/10?
You do a stick, and then you do 6 times.
Bigger. You're warm. You got the right idea. You've got it broken into 2 pieces. Color in a hole. Then I color in 6/10. This is distributive property, right? We're going to break it into 2 pieces. Distributive property sounds fancy, but really it's breaking it into 2 pieces or more, right? So I'm going to break this into my 1 whole. And it's going to take a minute, so make sure you're shading yours along with me. I'm not going to do a shading job that makes Miss Womack proud, I don't think. One whole. Five, 6/10. Oh, I did them. I flip-flopped it backwards. Even though I did this one vertically, can I flip-flop them around to do the other one horizontally, and will it work?
Yeah.
Yeah, what property?
Distributive.
Distributive is when I broke them apart. What property says I can move my pieces around? Associative says I can move my parentheses. Commutative, yeah, I just flip-flopped them back and forth. So my answer is going to come out the same because it's commutative property. Now, when I multiply, I have to multiply times 4/10, right? Which square do I use? Yes. This square or this square?
The signet square.
Okay. So I can do my 4/10 over here.
Yeah.
1, 2, 3, 4. Now you're warm, but what does distributive property say? When I break it into parts, do I just use some of them or do I use all of them?
Use all.
Yeah. So I can multiply this times 4/10, but I also have to multiply this times 4/10 as well, right?
Yeah.
So my answer is 64 hundredths, right?
Yeah.
Over here I have 1, 2, 3, 4/10. Yeah? 4 times 1?
Yeah.
Over here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 hundredths. 4 times 6? 24. Put them together, 64 hundredths. I know, right?
You can just add it.
Yeah, you can just add it because it's distributive property. We took 4/10 times 1, 4/10 times 6/10, put them back together, took it apart because it was easier, put them back together in the end because remember it's all apples in a bowl. If we do the multiplication, it doesn't matter how many pieces we break it into, we throw it back into the same thing and our answer comes together in the end. 64 hundredths. So this was the only way I have ever managed to actually show why when you multiply two decimals together, you get a smaller number. Because when you take this and multiply them together, you're looking for a piece of 3/10 that is equal to 4/10 of that. So we end up with a smaller piece of a piece when we multiply two decimals together.